Alrighty, it is July and we are going live for Cocktails and Fishtales with the fabulous Emma Beck here. And I'm of course the host, Tina Troyer with Harbor WildWatch. And it's a beautiful day outside. So we're hoping that we get some people who, maybe you want to take your beverage of choice out to your front deck, wherever you want to go, get cozy, settle in, because let me tell you folks, it is very exciting that we get the chance to combine students and Harbor WildWatch data in a magical oyster story this evening. So while you're getting settled, we of course like to ask our presenters what their favorite cocktail and biggest fishtail is. But in the spirit of virtual things, we can have folks who are not 21 yet. So Emma, being that you're not of the legal drinking age, please tell us your favorite mocktail rather and a wild fish tale.
Hi, so I really like Arnold Palmer's, but tonight I have a mocktail with me that is fresh squeezed orange juice.
Oh, love it, love it.
Yeah. Favorite fish tale. Well, I grew up in Arletta, across from Fox Island, and one time in the summer we had it was a baby giant Pacific octopus, and it washed up on our beach, and me and my brother and sister found it, and it was about 4 inches long. It was bright orange. Yeah, so that was pretty exciting.
Awesome. Yeah. I like the fishtails that you're not, I got an octopus this big. Like, no, the cute ones are darling too. And thanks for not putting it on your face, because that's what I like to do with cute sea creatures, is like put them on my nose. But we know from someone else's experience, don't do that. So with that, for those of you who are tuning in, go ahead and write in the comments where you're watching from. We'd love to know that. And of course, that's the space for you to type your questions, and we'll have Emma answer those questions live at the end of her presentation tonight. So sit back, relax, and let me delightfully welcome the lovely Emma here. She's been out in the field with us collecting oyster data, but she is really just being a rock star out at UW. She's a student of marine biology and math, I believe, and is working up the oyster data we've been collecting over the last, well, I guess it's not fully a decade. We've been doing beach monitoring for a decade, but the oysters stuff is something that we started noticing a little later on. And so Emma's here to tell us more about the oyster story tonight. So Emma, I'll turn it over to you.
Thanks, Tina. All right, so tonight I'm going to be talking about some research that I did last summer, and then also research I've been doing throughout this year and beginning again this summer. So like Tina said, I'm a student at the University of Washington, and last summer I was working with Harbor WildWatch data, looking at population counts over time. So I'm going to share a video presentation with you from my research last summer. And my presentation is going over population counts over time and some interesting findings I found with the intertidal species. So I'm going to screen share really quick. Here we go. And Stina, can you let me know if you can see that?
It is loaded.
Wonderful. All right, so this presentation is going over, it's from the Washington NASA Space Grant Symposium from my research last summer. So here we go.
I'm not sure that we're getting volume on the...
Oh, interesting. No volume?
At least I'm not hearing anything.
Okay. Do you think that's a setting, or?
No, this is a great question.
Maybe if I mute. Can you hear that?
Nope.
Okay, that's okay. I can share my research from this year, and then I'll share like an intro to the oyster story, and then I can go back and see if I can find the poster and just go through.
Perfect. Thank you.
Sound good? Okay, yeah.
Adapting to our technical difficulties here. I guess it seemed like it was all going to be easy peasy, but yeah. While you do that, I will figure out and see if there's.
Okay, sounds good. Okay, so this year I've been working with specific oyster data that I got from Harbor WildWatch, and I don't know if there are any Harbor WildWatch volunteers listening, but if there are, I'm definitely working with some of the data you collected. So I'm working on the non-native oyster performance in the Anthropocene. So I'm also working with the Roosink Lab at the University of Washington. Okay, so first of all, the importance of my project, the role of oysters in the ecosystem. First of all, oysters provide a lot of water filtration. An adult oyster can filter around 2 to 2.5 gallons of water per hour. Also, oysters provide reef habitats. So when they're young, they're floating around in the water column, and then they form hard shells and they settle onto hard substrate, and that's often other oyster shells. So they form these large reefs that build up. And those reefs provide habitats for a lot of other intertidal species. So those are often shrimp and fish. And oysters also create these large wave barriers. So you can see in this diagram here, there's an oyster reef right here, and then it blocks the waves from eroding the shore. We also have a booming shellfish industry in Washington state with an annual harvest of about 107 million. So there are a lot of companies that are really interested in oyster performance. So this summer, I'm working with data on the non-native Pacific oyster. There are two types of oysters primarily in the Puget Sound. We have these very small Olympia oysters that you can see over here on the left, and these are the native oysters. And then we also have these large Pacific oysters. So there are a couple differences in Olympia and Pacific oysters. The main one, as you can see, is size. Pacific oysters can reach around 12 inches, and Olympia oysters are usually only around 2. However, Pacific oysters are also a lot easier to grow. So the reason we've been seeing this huge increase in Pacific oysters over the last 100 years is that growers are bringing them in from the coast of Japan. And Olympia oysters were over-harvested at the turn of the century, and then all of these Pacific oysters were brought in, and we've recently been seeing them reproducing in the wild in Puget Sound. So my research question for this summer was, how does water temperature relate to oyster recruitment? So there are countless studies that show that oysters recruit better when there are higher water temperatures. So growers will use water temperatures of around 17 degrees Celsius to 22 degrees Celsius. And we've recently seen oysters reproducing in the wild in Puget Sound. And we're wondering, does that have anything to do with the waters warming up? Because if it does, we'll probably see more and more oyster recruitment as climate change increases the water temperatures. So this is a photo of me at a Harbor WildWatch monitoring event. This was last summer, and I'm over here on the right. And we're doing a presence-absence survey in this photo. This is a map of all of the sites where the data comes from. So if you are Harbor WildWatch volunteers listening in, you've probably collected data at least a few of these sites. So here we have Purdy, Kopachek, Demolay, Penrose, and Maple Hollow. And then we have 3 eastern sites. And I'm also working with water temperature data from right here in Carr Inlet and over here in Commencement Bay. So the interesting thing about this data is we've been seeing oysters showing up, in the western sites over here in Carr Inlet. And the water temperatures are usually quite a bit warmer in the western sites. However, over here by the Narrows, the water is often a lot colder, and we haven't seen any oysters showing up on these eastern sites. Okay, so this is a graph that shows water temperature over time at the two sites that I showed back here. There's the Carr Inlet one and the Commencement Bay site. So here we have the blue is the Carr Inlet site, and the red is the Commencement Bay site. So as you can see, over this whole, over these 2 decades, there's been reliably warmer water temperatures in the Carr Inlet site as compared to the Commencement Bay site. Now, we've only seen oysters showing up since about 2015. And the interesting thing is we can see this spike in water temperature here in 2015, which is right about when the recruitment began. This is a graph I made that shows the relationship between recruitment and temperature. So you can see temperatures over here on the x-axis, and we have recruitments, the number of small oysters that were counted, up here on the y-axis. And you can see there's a kind of positive correlation going on here. There's a really large recruitment event up here at Kopaschucks. There were a lot of baby oysters counted one year. And then you can also see this is color-coded between the eastern and the western sites. So the western sites, remember, are the really warm ones. And this is where we're seeing all the recruitment occurring. And we're seeing it occur more at the higher temperatures. And then on the east, we haven't seen any recruitment at all, and the temperatures tend to be lower. So that's the end of my intro to my oyster research this year. I am writing up a paper right now that I'm going to be submitting to a journal, hopefully by the end of the summer. My general timeline right now is soon, but that's pretty exciting. And I'd like to thank Harbor WildWatch and the NASA Space Grant Consortium and Professor Jennifer Rusink's lab. Also later this summer, I'm going to be working with Professor Rusink's oyster data from across along the West Coast, which is going to be really interesting to add to my knowledge of the oyster data. All right, that is the end of my intro to my research. Thank you for listening.
So thank you, Emma. Stoked to have somebody actually doing something with the data we collect, because it's exciting to kind of be able to actually see it. And I think those graphs tell a pretty cool story with the temperature relationship with the oysters being able to recruit out. I did look up, it sounds like it might be possible if when you share the video that you have, there might be, I think in the bottom left, there's like share with computer sound option. So I don't know if you want to try doing that.
Okay. Share with, share sound. There we go.
Sweet.
Should I optimize it?
We got the teaser before we get the meat, but you know, dessert before dinner is often a good recommendation. So
yeah, for sure.
Try this again.
All right, so this is my video presentation of my research from last summer, and I was looking at population counts for all sorts of species from Harbor WildWatch monitoring. And there's some pretty cool findings in here. Also, look out for the findings on the Pacific oysters, because this is kind of what began the whole Pacific Oyster Project. Okay, here we go. See if the sound works. Hi, my name's Emma Beck. Yes? Oh, perfect. Wonderful. Hi, my name's Emma Beck, and this summer I studied the intertidal populations of the South Puget Sound, and I discovered a few surprises. First, let's do the background. All right, so we have a tidal zoning scheme here that I made, and we can see there's the 0-foot tidal height here, which is calculated based on the low tide from a lot of years. We also have a lot of different species. Also, if you want to follow along on your separate poster, you're welcome to do that. Just listen to the audio. Okay, so we have a couple species here that I worked with. I worked with barnacles, a lot of different species of barnacles. I worked with Pacific oysters, which are not native to the area. They're actually from the coast of Asia, but they've been showing up. And I also looked at limpets and sand dollars. And you can see here are the areas of the beaches where the sand dollars, Pacific oysters, limpets, barnacles, and sea lettuce show up. Sea lettuce is that green algae that you'll see on the beaches around here. All right, so I use data from Harbor WildWatch, which is a nonprofit in Gig Harbor that supports community science. And they collect data from 4 different tidal heights, from -1, which is down here, 0 foot, 1, and +5 foot tidal heights. All right, let's move on to locations. So Harbor WildWatch actually collects data from 11 different beaches in the area. I only looked at 2 though. So the ones I looked at are Penrose State Park right here with the famous spit, and also Maple Hollow State Park, which is about a mile away. Okay, let's look at some photographs. So here we have limpets, eccentric sand dollars, a lot of barnacle species, Pacific oysters. Remember, those are the non-native ones that are from the coast of Asia. They're often called Japanese oysters. We also have Ulva lactica, Ulva intestinalis showing up right here. And we have Chondrocanthes acicularis. And remember, I am working with both red algae and green algae, which are combinations of a lot of different species. So the green algae is going to be that Ulva lactica and the Ulva intestinalis we see right there. And then red algae, one of the main species we worked with was the Chondrocanthes acicularis, which is down here. All right, so let's get on to the graphs. Okay, so this first graph we're going to look at is limpet count. And the limpets were just going crazy. So you can see here, there is a ton of variability. All right, the limpets are varying over time, they're varying between sites, they're varying between tidal heights, they are just going wild. All right, so you can see this huge spike here. That's a recruitment event. That means that there were a lot of juvenile limpets. You can also see spikes like crazy at the +5 tidal height. That's very high up on the beach, right? We also see spikes at the +5 over here at Maple Hollow, but they're not in the same place. These aren't following each other between the sites, right? So just a ton of variability in limpets. Okay, let's move on to sand dollars. This is one of my all-time favorite graphs from this summer. There's the coolest thing going on with sand dollars. All right, so first of all, you have to notice there are all these different spikes in this Maple Hollow graph, right? Do you see those? And it's kind of hard to see, but if you look really closely, you can see that because the turn of the year is in the winter, it'd be summer right here, right? So this is a summer spike, and then a winter dip, and then a summer spike, winter dip, summer spike, winter dip, etc., throughout the entire decade. And the weirdest thing is, this isn't sand dollars being born and dying off, because sand dollars can live, eccentric sand dollars, the one we're working with here, can live up to 13 years without predation. All right, so what's probably going on here is something else. We have 2 hypotheses right now. One, the sand dollars are actually settling down into the sand in the winter to protect themselves from the waves. Or 2, the sand dollars are migrating. Whole beds of sand dollars are just migrating to deeper water in the winter. I think that's really cool. All right, so this is my barnacle cover graph. And we don't have a ton of data on barnacle cover because we changed our data collection procedures. Harbor WildWatch changed data collection procedures in 2019. They used to be counting individual barnacles, but now they're doing percent cover. What we can see from this graph is that at the +5 tidal height, that's this peachy orange line, and at the light blue line, that's the 0 foot tidal height, they kind of follow each other between the sites. So similar habitats at these tidal heights. All right, let's look at Pacific oysters. So Pacific oysters, the weirdest thing happened in 2016, all right? So there weren't any Pacific oysters, none, from 2013 to 2016 at either of these sites. And then all of a sudden they just showed up, right? They're from the coast of Asia. So here you can see this gigantic recruitment event up here, right? Lots of juvenile Pacific oysters. And then there's a dip, of course, because there's natural thinning in the population and they're also growing in size, but we can't see the size data. All right, so you see a similar pattern here at Maple Hollow, but just on a smaller scale, right? It'll be really interesting to look at what happens to other intertidal creatures as the Pacific oyster populations continue on throughout the years, because these are new. Okay, let's look at red and green algae. So remember, these are conglomerations of a lot of different species. I showed you the photographs earlier. Okay, so this graph shows red and green algae at Penrose. And initially, when you look at it, it looks like those hollow curves you'll see in statistics that show competition maybe between species. And I got kind of excited, right? But it doesn't actually show competition. I'll show you why later. All right, so 2 things to notice. First of all, loads of green algae in the summer. You can see this huge red blob up here. The green algae is going up to 100% cover. That means these quadrats that they're collecting the data in are just thick with green seaweed, right? And the other thing you should notice from this graph is there's barely any red seaweed at all. The red algae cover goes to at most 5% through the whole decade, right? Okay, let's look at Maple Hollow. This is a very similar graph. 2 different things though going on. There's a point here where there's a really high red algae cover and also a really high green algae cover. And by really high, I mean 50%, which is the highest we ever saw throughout the decade at Maple Hollow. And then also there's slightly more red algae. See how this is more spread out towards the right? Slightly more red algae throughout the years, but not that much, Sue. Okay, so then now let's look at the line graphs. So remember I said that it probably wasn't competition because there's so little red algae? All right, this is what's really going on. These huge summer spikes in green algae. Green algae is coming up to maybe like 70s, 80s, 90% cover. That's a lot in the summers, and it's happening every summer, right? See this? And then it's also happening at Maple Hollow. And remember I showed you that point over here where there's a lot of red algae and a lot of green algae? That's right here in the summer of 2014. It's kind of cool to see it show up on both the graphs, right? Okay, so the really cool thing that's going on with the green algae here, I didn't see this initially, but what's going on is at Penrose, data was collected 1 week before the heat wave. Remember that big heat wave in July? And at Maple Hollow, the data was collected 1 week after the heat wave. And this is important because if you look at this final data point here at Penrose, this reaches its normal summer high, right? Even a little higher than previous summers, right? But then at Maple Hollow, after the heat wave, not only does the green algae not reach its normal summer high, which would be way up here, it actually goes down from its winter low. That's insane. This is the first time this has happened in the entire decade. It's gone down to 0% cover. So presumably there was a lot of green algae and then the heat wave hit and it just disappeared. So what's happening? What we're probably seeing is a huge decimation of green algae across the beaches during the heat wave. And it'll be really interesting. Harbor WildWatch collects data from 11 different sites. So it'll be really interesting later to look at what happened at all of the different sites with green algae. And then they'll collect data in the winter again, so we might be able to see some changes from the heat wave and other intertidal creatures. And this is going to be really important moving forward, because as the climate heats up, we're going to have more and more heat waves like this, and we need to know what's going on. All right, so just to recap, the main 3 things we found this summer in my research was, first of all, the sand dollars are actually migrating in the winter. Whole sand dollar beds are migrating. That's really cool. Second of all, there are suddenly all these Pacific oysters from Japan showing up on the beaches in the area. Third, green algae was just killed by the heat wave, right? Just decimated. It'll be interesting to see what goes on later with other intertidal creatures from the heat waves. All right, so if you have any questions, let me know. I'd be happy to answer them. Thanks for coming.
That was great, Emma. That I didn't know sand dollars because I have 13 years. That's my first fun data. The sand dollar data is new to me. That's wildly cool. For those of you tuning in, now's a great time I'll be peeking over here to look at your questions coming in. So happy to filter those over to Emma. But I just want to say congratulations on taking a whole wild slew of data, because I'm imagining all the information you had to wade through to make some of these graphs and see some of these trends. And definitely for the barnacles, I'm thinking I'm curious if we should have kept counting them versus like going to the percent cover. I feel like you're welcome to those of you volunteering now who don't have to count individual barnacles at the beach, but also curious if how that count versus percent cover switch impacted your ability to look at that information.
Yeah, I was a little bit concerned when I first saw some of the data. There were individual counts that were in the 900s, and I was imagining you counting individual barnacles, but then I realized you probably do like a section and then.
Yeah, we do. That is true. Some subsampling where you're like, okay, we're going to count a fourth of this square and then we'll multiply it by 4 to give ourselves a little bit of a break. But sometimes people miss that memo and they're sitting there counting all of them and you're like, oh, whoa. Estimates are good too. But yeah, I think that led us to that shift to do more of the percent cover.
Probably a good shift, yeah.
Yeah. Peek over and see if anybody. Now's the time to have your questions answered live, folks. So type those in the comments and let us know what you're wondering. I'm curious, when you were out doing some of the beach monitoring with us, what was your favorite part of doing the fieldwork side of things?
I really liked, you guys found a midshipman fish in the really shallow water. And I forget who it was, but someone jumped up and was like, there's a midshipman. And then we went out and looked at it and it was like right in the shallow water. Because I think it may have like flipped up or something, but yeah, that was pretty fun. Also, there were some really interesting eggs on the bottom of a log.
Were they
Do
yellow?
you remember, do you know what those could have been? It was like you lifted up a log and there were just all these eggs all along the bottom, like a little nest.
Were they like golden yellow?
Yeah, they were.
Those were the midshipman eggs.
Nice, yeah.
Connect nicely with your extra additional fishtail going on here. But yeah, that's one of the important reasons why if you go to the beach and you're exploring and looking under rocks, always remembering to put your rocks back how you found them, because we're out at these low tides because tonight's a super moon. So there's great low tides if you want to come play on the beach. We're doing low tide beach walks this week. So come hang out and explore. But we've been seeing a lot of rocks that have been flipped and left over. And then the birds like eat all those eggs, which is great for the birds. They're having some delicious omelets out there, but not ideal for the next generation of midshipmen. So put your rocks back, people. All right, we have a question from Susan. Also a great, nice job, Emma. Susan says, do we anticipate that the Asian species entry in 2016 will have a negative impact? Great question, Susan.
Yeah, so that is a really good question. The Pacific oysters have been farmed in Washington for quite a while, but they've only recently been reproducing in the wild in the South Puget Sound. And when I first started looking at these counts, I was kind of wondering, because the Olympia oysters are the native ones, I was kind of thinking, it seems like there should be a lot of scientists trying to rehabilitate and like bring back the population of Olympia oysters. But I think honestly, because there's so many growers who are really invested in the Pacific oysters, which are easier to grow, it would be kind of difficult to like kind of squash that population and bring back the Olympia ones. I honestly don't know what the effect is going to be on the beaches once they've started like really reproducing all over. Yeah, so it'll be interesting to see.
Yeah, I will just chime in a little bit with that.
Yeah, go for it.
Noticing how, I mean, at this point, because like I'm thinking of Kopachuk and Penrose are places that they've been seeding oysters for who knows how long. That would be an interesting, I guess, do you know how long those places have been putting oysters out on the beach intentionally?
I'm not sure.
We could look that up. Yeah. But knowing that, like, you know, they're a harvestable species, they're delicious, and they've been around a long time, at this point, they feel somewhat naturalized to our beaches. And it's kind of amazing how much life will live on the shell. So the habitat that they do offer may be paired with the question of like, can the Olympia oysters coexist in the same space as those Pacific oysters, or is there a competition for space there? I'm thinking of Purdy Sandspit as a spot that we kind of more regularly see Olympia oysters, which is kind of a unique, cool thing because there's definitely not a lot of beaches where we see the native oysters that are here. But yeah, definitely the beaches in the warmer spots. I guess I'm curious. I'm guessing that the oysters we put out on the state parks are probably successfully reproducing when it's warmer. And then, you know, water is very mobile and spreads all those little larvae everywhere. And that was kind of that, wait, what are we seeing on these beaches? There's oysters everywhere. And then just to like dovetail that with what we saw this summer is a lot less oysters. And so I'm kind of curious how that heat wave during the low tide event maybe had a delayed mortality event on some of those harder shelled bodies that, you know, we missed that demise, or I don't know what morbid word we could say there, but missed the mortality event and are just starting to see that more in our summer monitoring. So we have more oyster data for you, Emma, and we're really excited to see what patterns and trends you work up as you explore the number side of things.
Been a lot of fun. Yeah, I'll look at the water temperatures for this year, because you're probably right that it's heat wave, but it'd be interesting to see if it were also cold.
Yeah. It's changing. Let's see. Susan has another question. Does Harbor WildWatch share its data with UW Puget Sound database?
I am actually at UW Seattle.
Perfect.
Yeah.
Cool. I had that goofed up. Sorry about
no,
that.
No, it's no problem. Yeah.
University of Washington.
Yeah. University of Washington in general.
Perfect. I will say there's the beach monitoring is following the Beach Watchers protocol. So there is through let's see, is it Sea Grant? I'm gonna mess this up. It's Jason Toft, who I think is Jason Toft at UW?
I don't know.
Oh man, my mind is blanking. Anyways, the idea with community science is that it can be comparable across a lot of different places. And so we have matched protocols with other organizations so that we can share our data. And we are, I think, well in the works of making that happen. And I would say this presentation is inspiring me to like, okay, it's really time to buckle down and get that entered. So looking forward to being able to maybe find some more patterns and trends. And by that, I mean, here's the data, Emma. Have fun.
Well, thank you for sharing the Harbor WildWatch data.
Yeah, we do have a couple monitors tuning in. We have Steph over here saying hi, been an instrumental human and counting, not
very
barnacles,
cool.
but other things. Yeah, is there, I guess, okay, another question I have is in deciding which species to look at, I know we see things like the checkered periwinkles and quadrats and, you know, woody chitons and every once in a while a sea star, or, you know, we probably have a species list of over 200 different things. What was it about the species you chose to kind of like pull out that how'd you find your species?
Yeah, so I mostly looked at species that had consistently pretty high counts, or species that had a lot of data throughout the whole decade, because those were the most fun to model. Like, for example, if you see like a few starfish, sea stars, I would then cut that species out because I would want to look at change over time. Perfect. It's easier to see that in a scatter plot.
Yeah, versus like, here's your one little spike of, okay, what does that mean? Oh,
yeah.
They're mobile.
Yeah. There's definitely a lot more, a lot of other species and a lot more information though to look at. So yeah.
Totally. Well, and if anybody else out there is getting inspired to ask us some questions, share your wonders, what can this data tell us? You have to ask the question to find out, I guess. So yeah, more cheers from the chat box about a great presentation. Is there anything else you'd like to share what a closing note for us, Emma.
Oh, I don't know. I'm really excited about writing up my paper. That's like my main huge excitement right now. So
I
I
will
don't know if there's a
say,
way to like share that, but yeah, if anyone wants to Google Emma Beck oysters in about 6 months to a year, please do so.
yeah, I imagine that when that paper comes out, you're gonna let us know, and
Yeah, for
we'll
sure.
definitely do some features in our Wildside Weekly newsletter, which if you're not signed up for, that's a great way to stay up to date with what adventurers Harbor WildWatch is up to. Lots of fun free programs, especially the low tide beach walks this summer. And since you're not going to get that newsletter today, go ahead and check out the Facebook page or our website to find different events to plug into this week. There's even a beach cleanup beach walk this weekend. So join us at the Purdy Sandspit at 1 down by the boat launch, and then we'll walk down over and meet the South Sound Surfrider crew to do a beach cleanup. And we might even see some Olympia oysters while we're out there. So we'll keep an eye out for those little cuties. But other than that, thank you so much, Emma, for joining us for Cocktails and Fishtales. I again am just so delighted to, have students doing science with our community science data. I think that's so freaking rad.
Thanks for inviting me.
Absolutely. And to all of you who tuned in, thanks for watching tonight. We'll have another Cocktails and Fishtales coming up in August. We are trying to determine if we're going to do that in person or virtually. So stay tuned for that. That will be with Chad from the Point Defiance Zoo and Aquarium about why we see jellies where we do. So it'll be a cool jellyfish talk. So yeah, we're featuring those, I think, less charismatic species, and we can still love them because they're awesome. So that, again, more love coming in through the chat for you, Emma, and thanks again for everybody for tuning in for Cocktails and Fishtales. Like I said, learn, have fun.